So far, we've met Python's scalar types. Scalar types contain a single piece of information. For example, an integer contains a whole number. A float contains a floating point number. A Boolean, either true or false. A string, a glob of text. Now we're going to move into the world of data structures. A data structure is just a container. And what it does is it holds related pieces of data in one place under a single name. All data structures have different rules for inserting, removing, access to data, or subsetting the data. So we're going to learn about those sorts of things. And the most basic data structures in Python are what I like to call the sequence types. There are two sequence types and a third that's sort of a phony sequence type, but it is and it isn't. Now, there are lists, tuples, and a string also behaves like a sequence type. We'll see that there's a great deal of parallelism between these, and we'll point out the differences and the commonalities as we go along. So let's begin by making a list. Here's how that works. You make a square bracket, and now to initialize a list, I can put some things in here. Oh, let's put cat food on the list. All right. Hey, one thing that's kind of interesting, lists are heterogeneous. They can contain objects of various types. And just to show you that, I'll put the meaning of life on my list. I'll put a little champagne on there. How about Elmer's glue wall? All right. So here's my list. And let's make a string just for kicks and grins. S is equal to A, B, C, D, E, F, G, H, I. All right. Now, watch this. The length of shopping is the number of items present in the list. There are 4. The length of a string is the number of characters present in it. So this string has 9 characters. One thing that's kind of interesting to do is, first of all, let's type in type of shopping. It's grocery shopping, but it's also a list. Okay, so we have a list here. And you might wonder, is it possible to cast a string to a list? Let's find out. I'm going to make a variable t, and I'm going to set it equal to list of s. Bam! Like a firecracker. All of a sudden, that string is exploded into a list containing strings, each of which is 1 character long. So we just exploded our string. Now, Humpty Dumpty, can we put it back together again? Yes, we can. And there is a string method called join, and let me show you what it does. If I put a string in here like caterwaul, all right, and I go dot join, and I pass in the list T, ooh, there's A caterwaul, B caterwaul, C caterwaul. You see that? So whatever string goes inside of here is the glue. And you say dot join. See, all the king's horses and all the king's men can put Humpty back together again. There he is. So it's not like he swallowed an M80 and it's irreversible. It's quite reversible. We can go back to the original state. And we use join. Join is a string method. Join takes any kind of sequence, and a list is a sequence, and it glues things together. Hey, let's try something on for size just for silliness. Let's try star dot join of cats. Well, look at that. Python's just going to say, oh, as a sequence, a list is a sequence of characters. And therefore, I'll just glue the sequence together with the glue star, and you can see join, kind of a cool thing. Now, lists have a friend called Tuples, which we will introduce shortly. And there is a difference between a tuple and a list, which you shall see. And I'll give you a reason. Well, why don't we go ahead and talk about that right now? Let's go T equals tuple. Some people say tuple, I say tuple. Let's say U is equal to tuple of T. That'll be nice and confusing. Now, watch what happens here. Oh, so indices give me access to items within the list. I have access to tuple items. Hey, that looks exactly the same. Why do we have two different things? Well, watch this. T square bracket 0 is equal to quack. All right, I'm going to just stick quack in there. What happened? Oh, items in a list are L values. You are allowed to overwrite them, replace them with other things. You can replace it with any type of object. Now, watch what happens when I try to do the same thing with my tuple. Tuples are like strings in that they are immutable. A list is a mutable object. Why is it mutable? Because what is the state of a list? Let's talk about state identity and behavior here. The state of a list is the collection of objects present in the list and the order in which they are present. Both of those jointly constitute the state of a list. The state of a string is the character sequence that is in the string. The state of a tuple is the same as the state of the list. It's the objects in the tuple and the order in which they are present. Tuple is an immutable version of a list. And you might think, why would you do such a thing? Well, allow me a little demonstration here. Let's make a list called refrigerator. Let's put Maple View chocolate milk in it. And let's go ahead and put Coke. Right, a bottle of Coke. And how about an apple pie? Bang. All right, so now we got some items present in here. And now I'm going to say icebox equals refrigerator. All right. Oh. It's kind of annoying to spell that. I shouldn't have chosen such an annoying word. But good old cop. Hey, wait a minute. Refrigerator is not defined. What happened here? You know what? I'm going to do this. I'll just do this. It's just, you give a long name to something and then you misspell it. Then you got to remember the misspellings, and that's just irritating in every way. Okay, so we have icebox and fridge pointing at a list. Hey, what happened? Oh. Yeah, now we'll do that. Okay, so here's icebox. Here's fridge. Now, what I'm going to do, lists are mutable. I can add a new item to the list. So I'm going to say fridge dot append what do I want to put in my, oh, bananas. Although you shouldn't store bananas in the fridge. No surprise here, right? But, ooh, so if I have two variables here, I have them and I assign one to another, they're now pointing at the same list. So any change either makes is a change the other one sees. This can be a problem. This is called aliasing. It could be a desired behavior. It could be an undesired behavior. With a tuple, since it's an immutable object, this cannot happen. You have safety. And in sophisticated programs, Python has something called threading. And two threads could decide, threads are autonomous subprograms of your program. And the two threads could decide to grab the same list at the same time. And if both of them are changing it, we could get some undefined, ugly, and horrible behavior. So that's why tuples are handy. Tuples are safe from a thread standpoint. Now, let's go ahead and start looking a little bit at lists. Now, one thing let's try this on a tuple. Let's talk. Do you think we can append to a tuple? Let's think about this for a minute. A tuple state consists of the objects present and the order in which they're present. And if you try to append to a tuple, you're changing its state. But since it's immutable, that's not allowed. So any operation that changes state can be trouble. Okay, let's see what we got here. So we're gonna make I'm gonna make a new list, and I'm gonna do something interesting. There's something called a range object, but I can pass it to a list. Watch this, because I don't want to do as much typing. I'm lazy. All right, I'm gonna say list of range of 10. That gives me a list containing the numbers 0 through 9. Okay, so if you say range of 100, you're going to get the numbers 0 through 99. So I now have this list. And let's make another list. Here's an interesting thing we can try. Let's go y is range of 10 and 15. And I'm going to put that inside. I'm going to cast that to a list. Ooh, look what plus does. Plus concatenates lists. Plus will take two lists and combine them together. And now we have x plus y. And that actually produces a brand new list. That makes a copy. So a copy of x goes there, a copy of y goes there, and now we have a copy of a list. If you ever want to copy a list, by the way, there is a smart way to do it. Say here's my list x, and I want a copy of it. Just go like this. Now, how can I tell, z and x? How can I tell that there are different objects? X is z is false. Is checks for quality of identity. So if you have two objects and you put is in between them, it's a relational operator. And what it does is it tests to see if they are exactly the same object. If they are not, it returns false. So we have two copies of this list hanging around. And a lot of times when you have a mutable object and you might want to do something to it but preserve its original state, you would want to make a copy, and then you could pound up on either the original or the copy. It doesn't matter because you have what was already there. Now let's look at some list behaviors that are interesting. They're going to be like string behaviors. Here's my x. Watch this. X:5. Lists have indices. For sequence types, indices work exactly the same way that they do in strings. Okay? They live in between the elements. Now, in is a little different. 10 in x, that's going to check and see if the object 10 is present in the list. So in for strings checks for a substring relationship. In for tuples or lists has an identical behavior, and what it does is it checks to see if that object is a member of that list. Now, here are other things we can do. We can do this. We can go from index 5 all the way out. We can do things like this. 1:3. And you can see 1 and 2 are the only things that are between index 1 and 3. All right. And you can also do this. X. Here, let's specify nothing, nothing. That's beginning and end. And if you do a 2 here, works just like strings. It will pick out every other element. So we have some of these interesting capabilities swimming around. Now, here's another thing you can do with a list. It's kind of interesting. So here I have my list X. Watch this. 2:5 is equal to lions, tigers, bears. Oh my. All right. What happened? Well, everything in the list between indices 2 and 5 has been removed. Okay? So that's 2, 3, and 4, and we have spliced in this new list. If you want to delete a part of a list, all you have to do is put an empty list on the right-hand side. I like to call this the Rosemary Woods behavior. Rosemary Woods was Richard Nixon's secretary, and she played a central role in the missing, mysterious 18 minutes in the Watergate tapes. So now we have lists and we have tuples. And lists and tuples, we can take subsets out of them. We can take subsets out of them. We can check for membership. What we can't do is we can't change the state of a tuple, but with lists we can append to a list and we can insert things in the lists. In fact, I think I'm going to break this video in two because there's a lot more going on here. So we'll have another part of this video, but for now, you know about the basics of lists, and I encourage you to get your machine out. In fact, you should have a terminal window open right now, and you should be experimenting alongside with me while you're watching these videos so you can learn for yourself.